Hello.
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 Yeah. Uh, you can hear me, right?
Yeah.
Yes.
Okay. Have you guys tried the questions that I had shared?
Yes.
Yeah.
Okay. Tell me which one, if there is a problem or something, anyone.
Um.
Mm,
I had given an assignment also. They had 50 questions.
Yeah. Yeah. I haven't started on that one yet.
Adam, what about you? Have you started that one?
no.
If you don't practice, you can't get better. It's very simple. What about the other two, three questions? Are there any problems with anyone, any question?
Um. I wasn't sure how to do the first question without using trigonometry.
Which question is that?
Um.
Page,
The
page of what?
rectangle,
Mm-hmm.
like the rectangle ABC, um, with AD equal to 3AB and points M and N divide AD into three equal parts. Find angle A and B plus A and B plus ADB.
Okay. Uh, Fine. So there is a rectangle ABCD. We can draw the rectangle. Hmm. ABCD, and point AD is equal to 3AB, and M and N divide AD into three equal parts. So M and N, these parts are equal. Uh, you have to find this angle AMB plus ANB plus ADB. So trigonometry solution is easy only, but we can do another method also. So from here, we will make another rectangle on top of it, which is congruent to the original rectangle. This is another rectangle. We'll label it BPQC. And there is a common side BC. Now, from here, we can draw parallel lines. From M, one line parallel to this side, and from N, another line parallel to this side. And we can call this point T. And obviously, PT is equal to 2 times TQ.
Yeah.
Right. Now, if you look at the triangle BNA, triangles BNA, TDQ. So basically join T and D, and BNA, TDQ, this triangle, and BTP. So join B and T and this triangle BTP. So
Um,
these triangles are congruent.
yeah.
Why? Because you can see that the base length is 2 by 3 of this side, and here also this is 2 by 3, right?
Yeah.
and one side is this, and here also one side is this, right?
Yeah.
And the angle is 90 here and 90 here, right?
Yeah.
Similarly for TDQ also you can do that, because this time this length is 1/3 of AD, right?
Yeah.
1/3 AD, and let me think, and this one is twice of this. So maybe this is a different type of triangle from the other two. Uh,
It looks the same.
no, 1 second. This TQ length is same as DN,
Yeah.
and this is twice of AB. In the other triangles, B and A, there is a difference. No, this is 2/3 of AD and this is AB. It's not the same type of triangle, so maybe that is incorrect.
Wait, why aren't they the same type of triangles?
Because this length, if this length was 3x and this length was y, the two other triangles that we have are 2x
Are
and
they,
y.
are they not squares? It says AD equals 3AB.
Yeah.
AD equal to 3AB.
Yeah.
So then this is x.
Yes.
So then there you have 2x and x.
Yeah.
Okay, then it is same, because this is also 2x and this is also x.
Mm.
Right, so then all the three triangles are congruent by SAS, right?
Yes. Yeah.
Yeah.
As soon as they are congruent, now we can equate some sides. For example, BT here will be equal to TD,
Um,
because it's the hypotenuse of this triangle and this is the hypotenuse of this triangle,
yeah.
Yeah.
right? So angle BTD angle is equal to 180 minus angle angle BTP minus angle QTD. So look at these. I am subtracting this angle and this angle. So BTD is equal to 180 minus these two, right?
Yes.
So 180
Um,
minus angle BTP minus and QTD. You can call that 90 minus QDT.
yeah.
So you are getting basically 90 minus angle BTP plus angle QDT, right?
Yeah.
BTP and QDT, but those are have to be equal because of congruent triangles, because this is opposite to the x here and this is also opposite to the x, right?
Mm.
These angles are equal by congruency.
Yes.
So the angle here is coming as 90, right? Angle BTD.
Yeah.
So this angle is coming as 90 and we already know BT is equal to TD. So the isosceles triangles, so this is 45 this much and this is also 45, right?
Yes.
Correct. Now
Yeah.
our job is to find AMB angle plus ANB angle plus ADB angle. These three angles we have to sum up. right?
Yeah.
The AMB, notice that that is, uh, 1 second, that is going to be 45, right?
Yeah.
This is X and this is X.
Yes.
So AMB can be replaced with BDT, right?
Yes.
And ANB, if you think of angle ANB, that is part of my triangle BNA, right?
Yeah.
That is the
Yes.
same as TDQ.
Okay.
Because of congruency, BNA and TDQ, if you look at ANB angle, it is opposite to the X here. So what is opposite to the X here? X here, opposite to that is TDQ, right?
Mm.
And similarly, ADB, angle ADB, we can keep it as the same. Don't touch it. We'll just replace BDT, TDQ plus ADB, right?
Yeah.
Yes.
So BDT is this angle, TDQ is this angle, and ADB is this angle. So it all adds up to 90, right?
Yeah.
Basically, this is a geometric solution where we drew another congruent rectangle on top and drew parallel lines and joined BT and TD. And then we looked at equal congruent triangles, right?
Yeah.
Okay, what else? If there is any other problem that you didn't get.
Um,
I also don't get the one of the rhombus.
Which one?
Points E and F lie on sides AB and BC respectively of a rhombus ABCD
Mm-hmm.
with AE equals 5,
Okay,
BE.
fine, fine. So E and F lie on the sides of a rhombus such that AE is equal to 5 times BE. So first we'll draw a rhombus. In a rhombus, all sides are equal, but the angles are not 90.
Yeah.
So we have A, B, C, D, and we have to mark a point E such that AE is 5 times BE. So it should be somewhere
yeah.
here. This AE is 5 times BE and BF is 5 times CF. So this is my E and F. It is known that triangle DEF is equilateral. So if I join EF and if I join this and this, triangle DEF is equilateral. Okay. You have to find angle BAD. BAD. Okay, this angle. Fine. So we have drawn this 5:1 ratio points here and here. What you can do is keep track of this distance BE and this distance CF and draw a similar point here with same distance.
Okay.
What am I saying? I am saying that draw a point K such that AK is equal to BE is equal to CF.
Yeah.
Obviously, since it's a rhombus, BE and CF are same. You understand that, right?
Yes.
So we are drawing a similar point here K, and we are going to consider the triangles AKD, AKD and CFD, we are going to think about them. Right? So think about what we can say about it. It is congruent
Yes.
by simple
Yeah.
SAS, because this length and this length are same here and here, right? And the angle is also matching. Why is the angle matching?
Um, because the opposite angles of the rhombus are equal.
Because it's a parallelogram, so opposite angles are equal, right?
Yeah.
The angles would not have matched if we compared this and this, right?
Yes.
That's why we had to take a point here and a new triangle like that.
Yeah.
Correct? So now we can say that because of congruency, dk is equal to df, which is equal to ed, right? Because
Yeah.
this is because of equilateral, this is because of congruency.
Yeah.
So
Yes.
now we know that dk is equal to ed, right?
Yeah.
So now let's think about this. The triangle DKE has become isosceles.
Yeah.
So the angles here and here must be same, right?
Yeah.
Okay.
So, okay, so if this angle is equal to this angle, then if you look at the 180 minus of that, this angle should be equal to this angle, right?
Yeah.
Correct?
Yeah.
Yes.
So angle AKD must be equal to angle BED, right?
Yes.
And now we do congruency of a different set of triangles. We do congruency of BED triangle and AKD triangle, right?
Yeah.
Look at these two triangles. Again,
Okay.
we have one length here which is matching to this length, and we have DK is equal to DE, right? And we have the angle here also matching this angle. So SAS again. Do you realize that SAS works again here?
Yes.
Yeah.
So this triangle is congruent to this triangle. So that automatically means that the other parts are equal now, which means AD is equal to DB, right?
Yes.
BD is equal to AD and AD is equal to AB,
Yeah. Oh.
right?
Yes.
So now what we have is that the triangle ABD is equilateral, right? Correct.
Yes.
So this angle is
Yes.
60.
I
All of
was trying
hmm.
like a I was trying like a similar thing, but I put my K like as an extension of AB. So
Okay. So then it will become a little difficult because the first
yeah,
congruency depends on the opposite angles being same.
yeah, that's I didn't
Right.
really get it.
You have to try a point K, but you have to think of where to place it. But first congruency, if you get, after that, slowly everything comes.
Yeah.
Okay. Is there any other problem that was not solved?
I didn't fully solve C.
What is C?
I mean, the third question, question 4.
Which one was it? What is the question saying?
It said Um, Points E and F lie on sides A, B, and BC respectively of a rhombus ABCD with um
You're just saying the same question.
yeah. Oh wait. I mean question four, sorry. In ABCD, B equals 40 degrees, E is the midpoint of BC, and F is the foot of perpendicular from A to DE. Find DFC, so on.
Okay, so there is a rhombus, angle B is 40. Uh, this angle B is given as 40 degrees and E is midpoint of BC. E is midpoint. F is the foot of the perpendicular from, okay, so first we join DE and F is the foot of the perpendicular dropped from A to DE. Okay, our job is to find the angle DFC, right?
Yeah.
This angle is given as 40 degrees. Okay, fine. Uh, okay, so this line DE is the line from D to midpoint here. We can extend it. It will meet the this side somewhere. 1 second. We'll extend this side of the rhombus and we'll extend this line.
Mm.
It will meet somewhere, let's call it G. Uh, okay, so now let's look at the triangle here, BEG and the triangle DEC.
Mm.
Correct?
Yes.
It is obviously going to, not obviously, but what we know for now is that vertically opposite angles are equal,
Yeah.
and we know that this angle is 140 degrees and we know this angle is 140 degrees
Yeah.
because it's a parallelogram, a rhombus, right?
Yes.
So two angles are same and one side is same. EC is same as this, right?
Yeah.
EC is same as BE. So these triangles are congruent,
Mm.
right?
Yeah.
Because two angles being same already makes it similar triangle, and if one side is matching, then the ratio of similarity is 1.
Yeah.
So therefore, now that we know it's congruent, we can say BG length must be equal to CD, and CD was equal to BA, right?
Yeah.
Okay. Also, uh, we know that this is a right angle triangle. Triangle AFG is a right angle triangle, right?
Okay.
Because this is 90.
Mm.
Uh, then and notice one thing that B is the midpoint of the hypotenuse, right?
Yeah.
B is
Yeah.
midpoint of hypotenuse of right angle triangle,
Yes.
correct?
Yes.
So if I connect B to F, that is a median, right? Obviously, from in the triangle AFG, BF is a median.
Okay.
Is that a doubt or something?
No, yeah, I understand.
No. Yeah.
And where is the circumcenter of a right angle triangle?
B, like the midpoint of the hypotenuse.
Um.
Midpoint of the
Yes.
hypotenuse is the circumcenter. So midpoint of the hypotenuse should be equidistant from the three vertices, right?
Yeah.
So in this right angle triangle, midpoint of the hypotenuse is B. We already know BA is equal to BG. So it should also be equal to BF.
Yeah.
BF is equal to BA is equal to BG. We are getting. Right?
Yeah.
Yeah.
So now if you look at the triangle CBF, CBF, we know BA is equal to BF and BA is also equal to BC, right?
Yeah.
Triangle CBF is isosceles, right?
Yeah.
Why? Because BF is equal to BC.
Yeah.
And we can also say the same for triangle FBA. That is also isosceles. Because
Yeah.
there also BF is equal to BA, right?
Yeah.
Yes.
So angle BCF plus angle BAF and BCF. Those two angles let's think about it. What we know is this angle is X and this angle is X, right? And what we also know is that this angle is Y and this angle is Y. Correct?
Yeah.
So when I say BCF, I'm saying Y and BAF, I'm saying X. Y plus X is equal to this Y plus X, right?
Yeah.
So clearly that is equal to angle CFA. Correct?
Yes.
Yes.
And now if you look at the quadrilateral ABCF, quadrilateral ABCF, right? In that, we have this angle plus this angle is actually equal to this angle, right?
Yeah.
So when you
Yeah.
add up everything, you get 2 times of CFA. That is the sum of these three angles, right?
Yeah.
Yes.
Plus this angle, which is 40. Correct?
Yes.
Should add up to 360. From where we get CFA angle is 160,
Mm.
right?
Yeah.
So if CFA angle is 160, then you look at what was DFC. DFC will be equal to angle DFC is equal to 360 minus angle CFA minus angle AFD, right?
Yeah.
Yeah.
But we know CFA is 160 and AFD is 90.
Mm.
So this is 110 degrees, right?
Yeah.
Which is what we wanted.
Mm.
Basically, the point here was extending this, and noticing congruency between this and this triangle. And after that, we joined F to B also, and we got two triangles which are isosceles. And also the important thing to realize was right angle triangle midpoint of hypotenuse is circumcenter.
Yeah.
Yeah.
It's angle chasing and these basic properties only, nothing very strange or something. Okay.
Right.
Okay. We'll continue with questions related to similar triangles. This is the first question. Similarity is what we are going to focus on. Let ABC be a triangle with AB equal to AC and angle A is equal to 108 degrees. Prove that AB by BC whole square plus AB by BC is equal to 1. This is the first question. And the second question is this. Triangle ABC
Mm.
has no obtuse angles. A point D is taken on side AC so that AD is equal to 3 by 4 AC. Find angle A knowing that line BD divides triangle ABC into two similar triangles. These two questions I want you guys to try. You have 10-15 minutes. Try it out.
Okay.
The first one, any ideas?
You
Um,
can draw a regular pentagon.
Regular pentagon?
Yeah, because then you get like a lot of similar triangles or like congruent triangles.
Hmm, you can do that. But without that also you can do. If there is a triangle ABC which is isosceles. ABC. AB is equal to AC is given. And angle A is 108. Right?
Yeah,
In that case,
yeah,
the other angles are 36 and 36.
yeah,
yes.
We have to prove that this result is valid now. AB by BC whole square plus AB by BC is equal to 1. So, okay. What you can do is try to take advantage of this 36 and 36 and make another line from here which meets it somewhere here and make sure that this angle is 36.
Yeah.
Because if you do that, then you have 36, 36 here, right?
Yeah.
So this angle will become 108, right?
Yeah.
Yes.
So we can say that the triangle DBA is similar to the triangle ABC. Correct?
Yeah.
Because all the angles are same. So now we can write similarity ratios here. And in the big triangle, you can do AB by BC because that is what we need. AB by BC, which is the angles across the 36. So in the small triangle, that will be equal to BD by AB, right?
Yeah.
Do you
Yeah.
understand what I'm saying?
Yes.
Yes.
By similarity, this ratio has to happen.
Yeah.
Uh,
Correct?
Yeah.
yeah.
Now, if you look at the other triangle, triangle ACD, this is 36, this is 72, and this is also 72, right?
Yeah.
So this triangle is
Yeah.
isosceles. Triangle ACD is isosceles. And what that means is CD is equal to AC.
Yes.
Okay. So BD would be BC minus CD, and which is the same as BC minus AC, right?
Yeah.
Yeah.
And since AC is equal to AB, this is BC minus AB.
Oh.
Correct?
Yeah.
Yes.
Then you just put that here. You get AB by BC is equal to BC minus AB by AB. So this is equal to BC by AB minus 1. So you're getting AB by BC plus 1 is equal to BC by AB. Right?
Yeah.
Multiply
Yeah.
both sides by AB by BC. You get AB by BC square plus AB by BC equal to 1.
Yeah.
So basically what we did was we got a triangle, isosceles triangle. We just made a construction where we made a point D with same angle 36, 36. And we wrote this ratio. Once we wrote this ratio, after that the other triangle was clearly isosceles. So CD was equal to AC. And here in this BD we replaced with BC minus AB.
Yeah.
Is it clear what is happening?
Yeah.
Yeah.
You can do your regular pentagon thing also. I'm sure it can come because regular pentagon and all has similar angles. 72-degree at the center and so on. So you might be
Yeah.
able to get it from
Uh,
there also, but this is easy only. It's not very difficult.
Yeah.
Okay, question number 2. Here we have triangle ABC with no obtuse angles. And D is a point on AC. AC such that AD is 3 by 4 AC. And you have to find angle A, knowing that BD line divides triangle ABC into two similar triangles. Your job is to find angle A. See, this condition is a little critical. The BD line should divide triangle ABC into two similar triangles, and triangle ABC cannot have obtuse angles.
Yeah.
So, for example, if this angle here, if angle ADB is bigger than 90, what will happen? Let's think. Then, if this angle is bigger than 90, okay, then it will going to be the sum of the other two angles. And the third angle is smaller than 90. Okay.
This does not make sense.
What?
This doesn't seem like it's possible for them to be similar.
It is possible. You have to think about how. You are on the right track though. Why it is not making sense, you have to figure out what will make it make sense.
Uh,
1 second. This AD is 3 by 4 of AC.
Mhm.
If this angle is bigger than 90, can we show that it's not possible? That's what I'm trying. Okay. So then
Yeah.
this angle is clearly not equal to this angle, right?
Yeah. Yeah.
But it also cannot be equal to these two, right? Correct?
yeah,
Yes.
Because it's actually the sum of this and this, right?
Yeah.
So this angle of triangle ABD will not match any of the angles, no, then.
Yes.
Do you understand?
Yeah.
So then it
yeah,
cannot be dividing, that the BD line does not divide it into two similar triangles, right?
Yeah.
Why? Because is if this triangle and this triangle are similar, some of the angles should match. No?
Yes.
So if ADB is bigger than 90, it cannot be equal to this, it cannot be equal to this or this, right?
Yeah.
And if similarly, if
Yeah.
ADB is less than 90, also it won't work. Think about it.
Yeah.
Same issue.
Yeah.
It cannot be equal to this and it cannot be equal to these two, right?
Yeah.
Because it's actually the sum of these two. So it is definitely bigger than these two.
Oh, okay.
So again, there will be no similar triangle, right?
Yeah.
The only way for it to happen that no obtuse angles and divides the triangle into two similar triangles is if ADB is equal to 90.
Mm,
Because if it is equal to 90, then this is equal to this.
yeah.
Then there is a possibility of similar triangles at least. Correct?
Yeah.
Do you understand what I'm saying?
Yeah.
Okay, so then what we will say is angle ADB is equal to angle CDB is equal to 90. Right?
Yeah.
Okay. Then we know what BCD and BAD. Okay, we know that they are similar triangles, right?
Yeah.
So if they are similar triangles, then which angles must match? We have to check. There are two options, I think. We already have this AB is opposite is matching with BC is opposite. Now we just have to check if, let's say, angle BCD is equal to angle BAD, right? That is one case, right?
Yeah.
Yes.
Yes.
Then BCD, let's call it X, and BAD, let's call it X. In that case, we have an isosceles triangle ABC.
Yeah.
Triangle ABC is isosceles in that case, right?
Oh, yeah. Yeah.
And then the altitude BD is an altitude,
Yeah.
is also a median. The altitude from the vertex of an isosceles triangle is a median, right?
Yeah.
But
Yeah.
that contradicts our condition that AD is 3 by 4 AC, right?
Yes.
Do you understand why this will not work?
Yes.
Yeah.
Because if this was equal, then the triangle is isosceles, then altitude is a median. But that is not given, right?
Yeah.
Therefore, hence, the only other option for us is angle BCD must be equal to angle ABD, right?
Yeah.
And angle
Yeah.
DBC must be equal to angle BAD,
Yes.
correct?
Yeah.
Yeah.
So now angle B, if you look at, angle B is ABD plus DBC. ABD plus DBC, and ABD plus DBC. DBC is same as BAD. So this is angle BAD. ABD plus BAD. That is angle B, right?
Yeah.
BAD and ABD, right? But that is actually summing up to 90, right?
Yes.
Because this third angle is 90 here, right?
Yeah.
Yeah.
So I know now that angle B is 90.
Mm.
This whole angle is 90, right?
Yeah.
Okay.
Yeah.
Then Uh, okay. So if I look at AD by CD, the ratio of the similar triangles, AD in this, which is opposite to this part, ABD, and CD in this, which is opposite to DBC. No, opposite to DBC. One second, maybe I'm making a mistake. Let's think. We have similar triangles, we have these ratios. So let's just write the side ratios now, right? In the two
Yeah.
triangles. I'm just going to write side ratios. So let's see what comes from there. So
Okay.
90-degree opposite is AB in the big triangle. And in this triangle, it is BC, right?
Yeah.
And then opposite BCD is this angle, it was equal to ABD. So in the big triangle, ABD's opposite is AD. And in the small triangle, this opposite to this is BD, right?
Yeah.
And finally,
Yes.
DBC and BAD. So it will be BD in the big triangle. And in the small triangle, it will be CD, right?
Yeah.
Yes.
This is the thing that comes from similarity. We already know AD is okay. So from here, what can we say? Um, AD by BD. Okay. Angle B is 90. Okay, so basically what we have is a right angle triangle, right? Right angle triangle with one altitude, right?
Yeah.
A,
Okay.
B, C, and the altitude like this BD, right? This is what we have, no?
Yeah.
We also have these conditions. Our job is to find angle A, and I know this much is 3/4 of AC, right?
Yeah.
So I think we should be able to find it. Let's see. So AB by BC. Right now we have done similarity between these two. We can also do similarity of any one part of it with the big triangle, right?
Yeah.
Do you understand what I'm saying right now?
Yeah.
We have done similarity of ABD and BCD so far, and from there we got this.
Yeah.
Correct?
Yeah.
We can also do similar triangles for ABD with the ABC, right?
Yeah.
Do you understand that they will be similar?
Yes.
So that's what I will write next.
Okay.
I will write the result if I do similarity between ABD and ABC. So you get AB opposite to the 90-degree in the small triangle and AC opposite to 90-degree in the big triangle is equal to opposite to A in the small triangle is BD and opposite to A in the big triangle is BC. And finally, opposite to this in the small triangle is AD and opposite to uh, angle C in the big triangle is AB. So this is the result we are getting from there, right?
Yeah.
So notice there is a AD by AB here, and there is a. Okay, so I can rearrange this and write AD by BD is equal to AB by BC. Okay, that didn't help us much. We already got that here also. So, okay, if I AD by okay, so what I can get is if I multiply this ratio and this ratio, I will get AD by CD is equal to AB by BC whole square, right? Do you understand what I'm saying? I have taken this ratio and multiplied it with this ratio. Since both are equal to this, I can write AB by BC whole square, right?
Yeah.
And that will cancel the BDs, right?
Yeah.
Do you understand what I'm saying?
Yes.
Yeah.
So now I know this ratio already from the question 3 by 4, right?
Mm.
No, 3 by 4 is wrong. AD by CD is actually 3 by 1, right?
Yeah. Mm.
So what I know now is that AB by BC ratio is root 3. Correct?
Yes.
And AB by BC is basically going to help us get the trigonometric ratio, no, for this.
Yeah. So,
This angle is theta, then tan theta is BC by AB.
yeah.
So BC by AB is 1 by root 3. So theta is 30.
Mm.
Correct?
Yeah.
Yeah.
So actually, I didn't need this other similarity. I just needed to use this along with this, right?
Yeah.
I
Yeah.
had a similarity here. So I just need to multiply this ratio with this ratio and cancel the BD, get AD by CD is AB by BC whole square.
Yeah.
And AD by CD is 3. So AB by BC ratio we have got as root 3.
Uh,
But the main part of the problem was to realize that the angle BD line has to make 90 degree.
Yeah.
Because if it doesn't make 90 degree, there is no chance that the BD line will divide it into two similar triangles,
Yeah.
right?
Yeah.
And then you have to realize that the altitude, one case is not possible because in that case, the triangle was becoming isosceles and altitude would become a median,
yeah.
Yes.
right? So a lot of basic triangle properties we are using, and now we are doing similar triangles type of questions, but it's all related to the normal standard properties that you already know. Okay. Write down these questions. You can try these. Let ABC be an acute triangle and let D be a point inside the triangle such that angle ADB minus angle ACB is equal to 90 degrees and AC times BD is equal to AD times BC. First part is find angle DAC plus angle DBC. Second part of the problem is calculate the ratio AB into CD divided by AC into BD. So that is the first problem. Question 2 is this. Let ABC be a triangle with twice of angle BCA is equal to angle CBA on the perpendicular bisector of BC. Consider 2 points P and Q such that angle CAP is equal to angle PAQ is equal to angle QAB. Let intersection of PQ and AC be called D. Now you have to prove certain things. Prove AQ into DP is equal to AD into PQ. Second thing is prove QP is equal to QB. And third thing is angle ACB is not equal to 15 degrees. These three things you have to prove in this setup. Okay. So these two questions, what I want you guys to do is to try these. We'll have a few more questions related to similarity before we move ahead. So one more class on similarity after this. One or two more classes. Okay. Have you guys written down the problems?
Yeah.
Just write down the questions. Also, Adam, the questions that you had shared are quite easy, I think. So
Yeah. This question 3 didn't make any sense to me.
it is correct only the question, but the hint is you should think of equilateral triangles.
Okay.
Look at the question, try to draw the diagram, see whether equilateral triangles makes it work and all.
Yeah, I got everything else.
Okay, fine. So we'll continue in 2-3 days and work on these two questions and try the assignment that I sent. There are a lot of questions there, but if you try it, those are the types of questions you might encounter in your IMAS second round and all.
Mm. Yeah.
Because it's not like it will going to be at the level of like international Olympiads.
Yeah.
It is going to be slightly easier but tricky, similar to the ones that I have shared.
Yeah.
So try those questions for sure before your second round happens, right?
Yes.
Okay, we'll continue
Okay.
in 2-3 days after. Yeah, after you guys have tried this.
Okay.
Okay, that's all for now then.
Thank you.
Bye.